So tangents and circumscribed angles. So as you guys know, with these new topics, you're always going to have to write some definitions. And I am recording now. So let's go ahead and read, what is a tangent? Who can read? Tyrone, you can't read? Why?
That's a bummer.
That is a bummer. Okay. Jalen, go ahead.
A suntan is a line in the same plane as a circle that intersects the circle. So many circles in exact one point.
You can keep going too.
The point where a suntan and a circle intersects is the point of suntans. Just see.
He's saying suntan. Okay, tangent. So this is a tangent line. So I know that the word tangent, we've seen it in triangles, right? Tangent. Tangent is what over what? Remind me again. Opposite over adjacent. Good. Oops, adjacent. Okay, that's a triangle situation. This is for right triangles. So when I say tangent in this unit of circles, we are not talking about that. It's the same word. I know it's the same word, but that is not the same thing that we're referring to, okay? So when I'm talking about circles, the tangent is the line that touches the circle at one point. So we would call this a tangent line. Today's lesson, I'll go back really quickly. Tangents and circumscribed angles. Okay. So that's my tangent line, and the point that it passes through is the point of tangent C. So go ahead and draw your diagram. And like I said the other day, if you have your compass with you, even better. Then you're going to have a nice, pretty, neat circle. If you don't have it with you, a cup works just fine. Anything circular that you might have around you works just fine. But the neater the circle, the better your notes are going to look. So SOHCAHTOA, when I'm talking about circles, doesn't really come through unless there's a triangle inside of the circle, right? So, if you have a right triangle inside of a circle, then we can start talking about sine, cosine, and tangent. But if it's just a circle and just a line, there's no triangles involved, then tangent has nothing to do with SOHCAHTOA. Anyone still need a moment to copy? Okay, keep copying. And good question, Tyrone. Is the tangent line also a chord? No, because a chord, that's a really good point. How many times does a chord touch the circle? Twice. So a chord is different because a chord is going to pass through the circle. Make sense? Cool. Okay, I'll give you guys about another 30 seconds. Good. Anyone else still writing? No? Okay. All right. We have a theorem. This is the tangent radius theorem. Who can read this one? Oh, there's Daniel. How about Rios? Can you read the tangent radius theorem for us, please? Okay, no. Man, it's just going to be Jalen. Samaj, can you read the tangent
That's
radius
crazy.
theorem, please?
If a line is tangent to a circle, then it's perpendicular to a radius drawn to the point of tangency.
Awesome. So exactly what she said. And you can copy this. You can actually copy this onto the same circle you already drew if you want to. But what you can end up getting is a right angle. It's a right angle when you connect the radius to the tangent line. So again, here's my radius. And here's my tangent line. When you connect them, you get a right angle.
The sun tangerine radiation theorem.
Someday I'm gonna say the wrong word for something, Jalen, and it's gonna be all your fault.
Happens to the best of us.
Thank you. That you just called me the best. Questions on this theorem? Now, as always, pretty much, we have a converse of this theorem, but that's basically saying the same exact thing. That if you have a perpendicular line, then the line is a tangent line. So it goes both ways. Anyone still writing? Okay, I'll give you a moment. Okay. All right. Now, last thing, take a look at this situation over here. Both lines are tangent lines, and the line AB is the diameter. So think about what we just learned and see if we can figure out what can you conclude about the tangent lines. So Perla's claiming that they're parallel. That's one claim. Does anyone have anything else? Janelle's agrees. Jalen says that they're perpendicular. So let's be very clear. Which two lines are parallel? So line A and line B are parallel to each other. And then which two lines are perpendicular? The tangents and the diameter. Good. So you were both right. You just had to be more specific about what you were talking about. So we know that we get a right angle over here and we get a right angle over there. And since both of these two lines are creating a right angle, they will be parallel to each other. So line A is parallel to line B, and line A is perpendicular to line AB, and line B is perpendicular to line AB. So if the tangents are passing through the diameter, they will be parallel to each other. Any questions on that? If the tangent goes through the diameter, if two tangents, so be very careful, if two tangents pass through opposite points of the diameter, they will be parallel. Just like in this example. They have to be across from one another, yeah. Opposite. Exactly. All right, so far so good. Now let's test our knowledge. Let's see. I only have 3 people from home today. And I know, Emily, does your microphone work yet? Because I know a while back it wasn't working. Nope. Okay. That's okay. So I heard from Samaj, I heard from Jalen. Rios, Rios has to step away for a moment. Awesome. So I'll read this one, but then after that, we're just gonna go in that order. It's gonna be Jalen, then Samaj, then Rios, then Miss Lopez, then Jalen, then Samaj, then Rios, then okay. So Maggie and Wei are measuring the distance across a circular fountain indirectly as shown in the diagram. They find that the length of RS is 15 meters. So RS is 15 meters. And the length of ST is 9 meters. So here's ST, that's 9 meters. And then it says RS is tangent to circle F, and point T is on the line FS. To the nearest meter, what is the diameter? What is the diameter of the fountain? Okay, so a couple different things. Since this is a tangent line, what do I know about this triangle? What do I know about this? What type of triangle do I have? We have a right triangle, right? Got a right triangle. Okay. Then let's see what else do I know about this? So I know that this is a right triangle because SR is tangent. If I extend this line, you can see that it is a tangent line. Do I know anything about SF? FT would be the radius, yeah. FT would be the radius. Do we know how long FT is? No. So all we have is this information. So I could call this one F, this one X. Is there anything else that I can fill in? Is there anything else that I can try to figure out? Maybe we can find the size of the sector. Well, what would we need in order to find the size of the sector? No? We would need a proportion, but we don't have enough information. That's okay. No, this is good. We're figuring it out. We're thinking through it. I'm not going to give it away yet. I'm going to let you guys struggle through it a little bit. Yeah, teamwork makes the dream work. Okay, so maybe we could do a proportion. So 15 over 360. But what's 15? Is 15? Not really, right? Find an angle measurement. Okay, so maybe one of the smaller angles. Maybe. This is not easy, is it? Nope. I'm not going to give it away. Don't worry. What? What's wrong with my face?
Just staring into my soul.
Can I explain it again? Okay, what do you want me to explain again? The question. Okay, hold on. Tyrone's telling me to wait. What am I waiting for? We're trying to find the diameter, yes.
Miss, I think I have it. I think I have it. Wait, oh, can you hear me?
I can hear you.
Okay. I'm sorry. Can we no, can we do the Pythagorean theorem and we do 15, x squared, because RF would be like the radius too. So if we find that side, then we can multiply it by 2, and then that would be the diameter.
That is correct. So let's try it out.
I said that in private chat.
What? No, you didn't. I didn't see
Yes,
it.
I did. I said, can we use Pythagorean theorem? I
Oh,
didn't
yeah.
explain it.
I didn't see
Bruh.
it. Okay, I'm sorry, Jay. I totally didn't see it. He did beat you to it. I'm sorry. Okay, we know that the radii are equal to each other. So both of those are x's because they are the same because both of them are radius. Okay, so even though we have two separate x's, let's see if we can fill in all the blanks for my Pythagorean theorem. So what would a squared be? $15 squared, good. B squared would be x squared. And c squared would be not just 9, but the whole length of that side would be what? 9 plus x. So think about it. The hypotenuse, the whole hypotenuse is 9 and x, 9 plus x squared. With me so far? Yeah, maybe. Think about it. So 15 squared, that's this 15 right here. X squared is this x right here. And then 9 plus x is the combination of those two parts of the hypotenuse. Okay, yeah? Okay, well, how do I do this? 9 plus x squared. What do I have to do? Think back to algebra. Not distribute.
The exponent first.
No. Well, kind of. When you do an exponent, if I'm doing to the power of 2, what does that really mean?
Wait, what?
When I take something to the power of 2, what am I doing? Janelli says it times itself. So this is 9 plus x times 9 plus x. And what do I do when I have 2 binomials, multiplying 2 binomials? I'm going to FOIL. So I'm going to do that. 9 times 9 is 81. 9 times x is 9x. 9 times x again, 9x. And x times x is x squared. Janelli's was going to say that. Good. All right, now I just combine like terms, so I get 81 plus 18x plus x squared. Now, that's just the right side. So far, all I've done, and I wish I had a little more room. Oh, you know what? I think I can get more room. Hold on. Yeah, okay. Oops. There we go. Okay. So far, all I've done is I've just expanded the right side of that whole equation. But now I got to put it all back together. So now I have 15 squared plus x squared equals 81 plus 18x plus x squared. And I know it looks really big, but don't worry because things are going to cancel out pretty soon. By the way, what's 15 squared?
Tom, use a calculator.
Oh, you should have that one memorized. What's 15 squared? Good, 225. Okay. Now we're just going to solve for x. It's just an equation. What can I do to both sides of this equation? We can do minus 81. Yeah, we can. Remember, when you're solving an equation, the order doesn't matter so much. What matters is that you do things correctly. So we're subtracting 81. And that's fine. What's 225 minus 81? Good. Okay. Is there anything else that I can bring over to the other side? Good, Janelli said it. We're going to subtract x squared from both sides. But what happens? They cancel. So I'm left with 144 equals 18x. So my final step, divide by 18. What do I get for x? X equals 8. Good. If x equals 8, then what's the diameter? Very good, guys. 16. See? Y'all did it. You guys did it. It was this was a really challenging question. So I'm really proud of you guys. I put it there for a reason. I wanted to see how much you guys can figure out all on your own. And you got the majority of the way there. So it was really just making sure that we're reviewing those little algebra skills that come back sometimes.
Rilla stole my answer and I'm still salty about it.
Okay, question from the chat. Why is the diameter 16? If x equals 8, why is the diameter 16? Because it's times 2. Remember that the diameter is 2 times the radius, and x was the radius. So if the radius is 8, the diameter is 16. Any other questions? Daniel was off by 1. Okay. All right. Let's move on. Oops. All right. Now I've got another definition. I think it's Jalen's turn to read. Can you go ahead and circumscribed angle?
A circumcised angle is an angle formed by two x-rays from a common endpoint that are sun-tangent to a circle.
Okay. So we've talked about inscribed angles. Now I have a circumscribed angle. And the couple of important parts to this. So go ahead and start copying down the definition and copy down the diagram as well. This is my common endpoint. What angle is formed to the radius? Good, 90 degrees. So we have a 90-degree angle over here, and we have a 90-degree angle over there. Because these two lines are both tangent lines. So when you have two tangent lines from a common endpoint, we get our circumscribed angle. Angle. Ooh, good point. Good point, Perla. We're not going to talk about dilations this week, but we will next week. Now, let's think about this question that I have here. What is the difference between an inscribed angle and a circumscribed angle? Good. One is on the inside of the circle and the other is on the outside of the circle. So I'm going to just draw really quickly to remind ourselves what an inscribed angle is. So with an inscribed angle, the common endpoint is on the circle. Right? Whereas a circumscribed angle, the common endpoint is outside of the circle. So that's kind of the biggest difference.
Make it symmetrical using the two angles in the front and in the middle.
The two angles in the where?
Can you repeat that?
Can you repeat what you said?
Oh yeah, my volume was low, so can you make it straight using the point in the front and the one at the common endpoint and the point in the middle of the
Okay,
angle?
so for
So
example,
if you make a line with that, does that affect anything?
good question. So let me draw it out so you can tell me if I'm doing it right. So like this. Is that what you mean?
Yes, that's what I mean.
Good question. So that would actually bisect the angle. So if you draw it through the center point, it would bisect the angle. Who can remind me, what does bisect mean? Cut in half. So that line right there is the angle bisector. Okay, so that's actually something we're going to talk about in just a moment.
Okay.
All right, cool. So there we have a circumscribed angle. Now let's talk a little bit more about it. The circumscribed angle theorem. I think this one goes to Rios or Samaj. I forget the order now.
Rios.
Rios goes next. Okay, Rios, go ahead. What is the circumscribed angle theorem?
It's me technically, but okay. Rios,
Oh, I'm
go
sorry.
ahead.
Samaj, you can go.
There's noise in my background, so Rios has to go.
Rios, come on, I know you're there. Go ahead and read. All your classmates want you to read. He's trying to make excuses in the chat. Rios, let me know what's going on. You read like last week. I feel like I heard your voice last week. Why? Something changed? Come on. Okay, Rios, just read for us. Rios, what's going on? You have 3 seconds. 3, 2, 1. Okay, Samaj, can you please read?
A circumscribed angle of a circle and its associated central angle are supplementary. It's not that hard.
Wait, where'd you come from? Hey, not in here. Get out of here.
Oh my goodness, that was too much, y'all. Okay, a circumscribed. Okay, so the associated central angle would be the angle that kind of makes it into a kite. Think of what a kite looks like. So on this example, angle, they're going to be supplementary. So angle AXB. What does supplementary mean again? What's supplementary? Thank you, Emily. They add up to 180. So angle AXB and angle ACB will add up to 180. So go ahead and write that down, copy it into your notebook, copy the diagram as well, and then we can go on to the couple of problems. Questions on this theorem? Anybody still writing? Perla, okay, finish writing. Stop bullying Tyrone. 30 seconds. Okay. Okay. Find the value of x. Think about it for a moment. Perla says 80. They are supplementary. But hold up, I just wrote down that the central angle is supplementary. So is that the same thing? Is it the central angle? What do you guys think? Is Perla right or is Perla wrong? And if she's wrong, then what would the answer be instead? Samaj is putting all her trust in Perla's intelligence. Okay. So we're not really entirely sure. So let's think about it for a moment. In this example, here's an arc, AB. What is the measure, or what is this relationship between AB and ACB? They're the same. They're equal.
They're equal. They're
They're equal.
symmetrical.
They're equal. So going back over here, I don't have a central angle. It's not there, but I can draw one in real quick. Here's my central angle. And I know that that x plus the central angle are going to be equal to 180. Well, if this arc is 100 degrees, how much is the central angle? Also 100 degrees. Let me give it a name. I'll call it AB. So arc AB, I'll call this C, is equal to angle ACB. So if the arc is 100 degrees, the angle is also 100 degrees. So Perla was right all along. Subtract 80, subtract 180, we got 80. How do we feel? Questions on that? Yeah, I had my evil smile on because this is something that by now should feel pretty normal. The central angle is equal to the angle that it intersects. They are equal. Central angle and the arc will be equal. So if they're showing you the arc rather than the central angle, it's no different. It's no different. It's still going to be that they are supplementary. Here's another. Try this one. Okay, Tyrone says B. Samaj agrees. Perla agrees. I'll give everyone a couple more minutes. I'm not going to say if you're right or wrong. Perla agrees with herself. Okay. Think about it for 30 more seconds if you don't have an answer yet. Janelle's agrees. Okay, so let's take a look. So from here to here, it's 220. So, okay, that's 220. What does that mean about the other part of the circle? How much is that? That would be 140. And what do we know between x and 140? I said, if that's 140, how do we get to our final answer? Good. They have to add up to 180. So x is going to be 40. Same idea as the previous problem. Just because the central angle isn't shown, even though they don't show it to you, the central angle and the arc are equal to each other no matter what. But in this case, we had to start by subtracting it from 360. So any questions on that? Okay. Okay, here's a question. KM and KN are tangent to circle C. Explain how you can show that KM is congruent to KN. So they're telling us that these two lines are congruent, KM and KN. How would we be able to show this using congruent triangles? So I want you guys to think back to what Daniel said a little while ago, because that was a good start. And let's think about it. What types of triangles could I make here? So K to C, okay. So I'm gonna split this in half, K to C, to make it into two right triangles, good. Here are my two right triangles. What else do I know about these triangles? Let's say I don't know yet if those two sides are congruent. That's what we're trying to prove. But what else do I know? Okay, KC is equal to itself. And the radius, there we go. Good, Perla. So CM is congruent to CN because both of those are radii and all of the radii are going to be congruent to each other. So MC is congruent to NC. And what else do we have? And we have the angle. So angle N is congruent to angle M. So what do we have? Which theorem do we have here? Think about it. I'm not going to reveal the answer yet. Yeah, why is it not side angle side? Right, because if it was SAS, the angle would have to be in between. So it's not SAS. Oh. It's not SSS, Tyrone, because we don't know anything yet about KM or KN. That's what we're trying to prove, but we don't know it yet. And then Perla's saying, well, technically we have SSA, but is that a theorem? No, there's no such thing as SSA. However, what type of triangles do we have? We have right triangles. Green side, the green side is the what? The base, or in a right triangle, what would the green side be? Green. It's the hypotenuse. What's the purple side? It's a leg. So what do we have? Perla was right. We have a hypotenuse and we have a leg. So we have HL. We have HL. And since we have HL, now I know that they are right triangles or congruent triangles. So now I can say that KM is congruent to KN. We just did a proof, guys. We just did a proof, and y'all didn't even know it. Yep. So I'm going to write it down in proof form, just to really get it down. And we just did a proof with like no fill in the blanks. There was nothing that we knew. It was all by ourselves. First statement we have is that Km and Kn are tangent, given. Since we know that they are tangent, we can say that angle M and angle N are 90-degree angles. That's the definition of tangent. Then we also said how, oh, my bad, hold on. We also said how the two, why are we praying? Amen. Okay. I was just catching up. Then we said that MC is congruent to NC, definition of a radius. And Tyrone, why can I say that KC is congruent to KC? Why? Good, reflexive. All right, so now I know that triangle KMC is congruent to triangle KNC because of HL. And there's one last step. Think about it in your head what it's going to be. KM is congruent to KN. Why? Not reflexive. KM and KN. There it is, Perla, CPCTC. There's our proof. There it is. We did it all by ourselves. You didn't even have a word bank. You didn't even have anything else. We really did it all by yourself, guys. Questions on this one? No, there is no homework on this. I couldn't find a good assignment on Khan Academy, so there is no homework on it. Okay. Let's try this one. What in the world? Did you guys hear that? That was so weird.
I heard it sound like a razor. Who's shaving that? I'm not gonna say that.
Someone's drilling. Okay. All right. Let's check out this one. This one's a little interesting. In the whose turn is it to read? Samaj. You missed it last time. Samaj, you better be listening. It's your turn. You're
They really must want to get that hair off.
Go ahead and read, Samaj. Yeah.
In the diagram below, AB, BC, and AC are tangents to circle 0. Is that a 0 or no?
I think it's an
At
O,
points.
but it looks like a 0. That's okay.
At points F, E, and D, respectively, AF is equal to 6, CD is equal to 5, and BE is equal to 4. Oh, what is the perimeter of triangle ABC?
Perfect. All right. So now I'm going to just label this. So AF is 6. CD is 5. And BE is 4. And then it's asking what's the perimeter. So I only know like parts of it, right? I only know these sections. So I got to fill in the rest. But what did we just learn about tangent lines? What did we learn about tangent lines that might be able to help? Okay, I know about the 90-degree rule. That's one part. That's not really going to help us in this case.
But B is 90. I'm pretty sure.
So all of these would be 90. But B itself, we don't know if that's going to be 90. But either way, we're not talking about angles. We want to know the perimeter of this whole triangle. So I want to know all the distance all the way around. But what am I missing?
Where'd everyone go?
I don't know. What am I missing? BF. I don't know BF. What else? EC and AD. But given what I know, given what we just learned about tangents, let me clear this up a little bit. What do I know about tangents? About circumscribed angles. What is true about the measurements of the line segments of circumscribed angles? They are congruent. They are congruent. So they both add up to 10? Where do you get 10 from? Oh, over here. Okay. So let's fill in what we know. We have 3 circumscribed angles, don't we? Here's one. So what do I know about the missing side?
It's congruent to DC.
To DC?
It's the same.
That's
And
not
choose
what
my
I just
eyes.
That's not what I just learned. What did I just learn over here? Think of that. Now look here. So the one that I highlighted in purple, how much is that one going to be? 5? It's not 5. This is 5. DC is 5. Six. Yeah, I literally highlighted it in purple. That was an easy answer. If DC is 5, then EC has to be also 5. If BE is 4, then BF is also 4. Because those are each of those angles is a circumscribed angle. And circumscribed angles have congruent sides. So that's the biggest takeaway, the biggest takeaway. I'll do one more example just to make sure we take that home. If you have a circumscribed angle that meets at a common point, then the two sides of it will be congruent. They will be congruent. So make sure that we understand that. So now go ahead and figure out what would be the perimeter. Good. 30. All right. Questions? Any questions? Okay, let's try another. Here's a really good one. This is like, this could be on a test. It's not from a test, but it was a really good question. I feel like this is what it would look like on a test. Jalen, I think it's your turn to read. Oh no, technically
Well, your turn.
It's my turn. It's my turn. Okay. Triangle STR is drawn such that segment ST is tangent to circle Q at point T, and segment SR is also tangent to circle Q at point R. Given any triangle STR with these conditions, which statement must be true? Think about it. This one's a little, you really got to think through it. And when you're ready, put it in the poll. Take another 30 seconds. Oh, everybody answered. Awesome. All right. So here's my responses. That looks pretty good, but let's talk about why. So it looks like answer choice C was the most popular answer. Obviously, a lot of people chose everything else as well. So not everybody, not the majority, chose C. So let's take a look. So I want to show you why I can disprove everything except for answer choice C. Answer choice C is telling me that STR is going to be isosceles. What does isosceles mean again? What's isosceles? Two congruent sides, at least. Well, what do we know about ST and SR? What do we know about ST and SR? They're both tangents, and since they are both tangents, they are congruent. They are congruent. So this is an isosceles triangle. Right? We agree? Okay. Now let's look at all the other answer choices, and I'm going to show you why they're not going to be true. So a lot of people chose B. So let me show you why B is not always going to be true. I'm going to show an example. So here's a different circle, but I'm going to do the same thing. It's telling me that I have two tangent lines. I'm just going to draw them in different places. So here's T. Here's R. And what if I put S over here? Actually, let me do this even better. Put T, R, and I'm going to put S over here. Okay. What happens? Okay, there's my two tangent lines. This one's a little crooked, but you guys get the point. And if I connect T with R, is angle S still smaller than angles T and R? No. Angle S is bigger now, right? But the drawing that I made still fits the exact description that they gave me up top. So just because it's a tangent line, yeah, in the original example, that statement was true. In the original, it was true. But the tangent lines could be coming from anywhere. They could come from anywhere all around here. It could be really close to the circle, or it could be really far away from the circle. And what's true? As you get closer to the circle, what would happen to the angle? As you get closer and closer to the circle. So if I go over here instead, what happens to that angle? As I get closer. Closer and closer, it gets bigger and bigger. Exactly. If I bring it really, really close, oh, it's not going to work out. There's a certain point where you can't make it work anymore. But that's true. They get bigger and bigger. So B is not always true. Let's check out A. A is claiming that TR could pass through the center. Okay. Well, if that were true, that would mean that TR is what type of line? What type of line is that? The diameter. Well, if I try to draw the tangent line, what do we already know? We saw this before. What happens? What type of lines do I get? It creates a 90-degree angle. And what happens to these two red lines compared to each other? They're parallel. Do parallel lines ever meet? No. So can I make a triangle? Or remember, if you were to make a triangle, you would need to meet at a point somewhere outside. So can I make a triangle? No, you can't. So A is incorrect. And then finally, D. D is claiming that the triangle could not be a right triangle. That's not true either, because, for example, what if you had, let me see if I can draw it correctly. And obviously, I'm just sketching this out. It's never going to look perfect, but I'm trying my best. Here's T. Here's R. And here's S. Now, it's not perfect, but here I have a right triangle. So it can be a right triangle depending on how close you get to the circle. So D is also false. So C is the only one that is always, always, always true, no matter what. No matter where the circumscribed angle is located, the two sides of it are going to be congruent. And it can be really, really far away from the circle, or it can be really, really, really close to the circle. And in both cases, those lines are congruent to each other. So that's the big takeaway from today's lesson. Does anyone have any questions? Questions? Okay. All right, we will finish up. I have some practice problems for you guys for tomorrow. Friday will be a review day and a quiz. So everything we've learned this week, we'll just continue practicing throughout until Friday. Have a great day, everybody. Goodbye, goodbye.
Bye, Miss.
Bye, Tyrone.